In this video, we're going to calculate some limits, some requiring L'Hopital's rule, some not. So, remember for L'Hopital's rule, we want to identify whether or not there's an indeterminate form. So if we look at the limit as x goes to 0 of this first one, plugging in 0 on top gives us ln of 1, which is 0, and plugging in 0 on bottom gives us 0. So this is a 0 over 0 case. I like to denote it as such, which means I'm going to apply L'Hopital's rule, which what I like to do is I like to put an h over the equals that can remind me and let other readers know what I did to get from one step to the other. Now we're still going to be taking the limit as x goes to 0, and L'Hopital's rule says you take the derivative of the numerator and denominator separately. That's important to remember. I don't need quotient rule for this. I'm going to do the derivative of ln of 1 plus x and derivative of x separately. So the derivative of the numerator is 1 over 1 plus x times the derivative of the inside, which is just 1. Now, the derivative of the denominator is just 1. Now, if we see what happens via direct substitution, we get 1 over 1 plus 0 all over 1, which is 1 over 1, or 1, and we've been able to calculate our limit, and we're done. Notice here I didn't write the limit notation because once I plugged 0 in, technically I've taken the limit, and I no longer need that. The second one, limit as x goes to pi of cosine of x over x. If I plug pi in, I get cosine of pi over pi. Now cosine of pi is negative 1, and pi is just pi. So we did not need L'Hopital's rule, and we calculated the limit to be negative 1 over pi. Let's look at a couple others. Again, remember, it has to be in indeterminate form before you use L'Hopital's rule. Don't plug it in blindly. So here if we check, if I plug 1 into that numerator, ln of 1 is 0, so the numerator is definitely 0. In the denominator, notice I'll have e to the 1 minus 1, or e to the 0, which is 1. 1 minus 1 is 0. So this, again, is a 0 over 0 case, which means I can use L'Hopital's rule to make it hopefully easier to calculate. Now we'll still be doing the limit as x goes to 1. On top, the derivative of ln of x is 1 over x. Derivative of the denominator, well, the derivative of 1 is 0. Derivative of an exponential will have itself in it, minus e to the x minus 1 times the derivative of the numerator, or excuse me, derivative of the exponent, which is just 1. So let's see what happens when we plug in 1 now. We'll have 2 times 1 over 1 over negative e to the 1 minus 1. So we're going to have 2 over e to the 0, which is 1, but making that negative. So we are going to have a limit of negative 2, and we're done. Now, it is completely possible that you may have to take L'Hopital's rule more than once, but for that one we only needed one time, and we were able to calculate it via direct substitution. Okay, again, first thing, direct substitution, see what happens. Plugging 0 in, I get 0 on top, and plugging 0 in on the bottom, I get 1 minus 1, which is also 0. So I have a 0 over 0, which means this qualifies for L'Hopital's rule. So we got the limit as x goes to 0, and now we take the derivative of the numerator and denominator separately, piece by piece. The derivative of sine x is cosine x, and the derivative of x is 1. So on top we have cosine of x minus 1. In the denominator, this is going to be a chain rule. So the derivative of cosine x is negative sine of 2x times the derivative of the inside, which is times 2, and the derivative of 1 is 0. Alright, so let's see what happens when we plug 0 in. Notice on top I'm going to get 1 minus 1, which is 0, and on bottom, sine of 0 is 0. So this is another 0 over 0, so we are going to need we can go ahead and use another iteration of L'Hopital's rule. So I'm going to use it twice. So I have the limit as x goes to 0, and now I'm going to take the derivative of cosine x, which is negative sine of x. The derivative of 1 is 0. In the denominator, Notice I've already got a 2 in there, so now the derivative of negative sine is negative cosine of 2x times 2, and we also have this 2 that was already in there. So let's go ahead and simplify that before we get any further. So limit as x approaches 0. I have a negative on top and bottom, so if I want, I can go ahead and cancel those negatives out, and so I have sine of x over negative 4 cosine of 2x. Alright, so plugging in via direct substitution, we get sine of 0, which is 0, over negative 4. And this is fine. If we get 0 over a number, our limit is simply 0. So in this one, we had to use L'Hopital's rule a couple of times, and you can use it as many times as you have an indeterminate form until you can solve your limit via direct substitution.